Hi guys, good evening. I would like to present a case study on linear discriminant analysis with Pokemon stars, which is like understanding dimensionality reduction for classification, presented by Vijender Reddy Mukesa. Coming to the next slide, introduction to LDA. LDA, which means linear discriminant analysis, which reduces the data dimensions while maximizing linear sparability of classes. LDA works by projecting the data on a lower dimensional space where the separation between different classes is maximized. And coming to why LDA, and we are focusing on LDA versus PCA. While LDA focuses on class separability, PCA focuses on variance. LDA is supervised and PCA is unsupervised. And coming to the mathematical foundation Bayes theorem and Gauss's distribution, like odd log odds of classes and linear boundaries are derived based on Gauss assumptions. And the key assumptions in the LDA is that the class follows a normal distribution with the same conversion matrix. And below is a formula, like a mathematical equation that gives Gauss's distribution. And coming to the application to the Pokemon data, using LDA on Pokemon stars, attack, defense, speed, and type, we consumed and we displayed the data. Like I'm moving from slides to the code, like VS Code right now. I would like to take a moment to discuss on the code. Like it's all stating like about linear discriminant analysis, and this is a graph. It is also stating like originally introduced by Fisher himself in 1930s. And in the below lines, like mathematical equations also there in this case study. And when coming to the core, like I have took this Pokemon data from the case study, like from inputs, and I have imported these few libraries, and I'm displaying three rows in the complete file. And here I am calculating the length of the Pokemon, so it is 386. And coming to here, we are also doing some column wise, uh, focus only on Pokemon with a single type. And here linear discriminant analysis LDA is calculated here. And then we are importing matplotlib, so to draw a heat map. So heat map, so this is in the x-axis we used to have attack, defense, axis, defense, speed, and HP. And the y-axis we used to have like water, steel, rock, poison. And these are the values that we got it from the CSV of LDA feature coefficients. And moving down to the slide, like moving down to the code, like we used to have a bar graph, like plot graph. Like we used to have different variants down on the line x-axis, and in the on the y-axis we used to have there is an interval of 20 to the 100. And coming down to the code, like we used to have accessing linear classification performance by applying the LDA projection. And after running the, I got a array of three values. And in the next code, like we used to have the same, like we are calculating the graph using that like two component LDA decomposition. These are the points, and the points are showing on the left are indicated here. And in concluded, I'm moving back to the slides. So in the slides, like we have we were seeing this heat map in the core and class wise separability. Like classes like rock and ghost Pokemon are highly separable, while ice and water are hardly to separate. If classes have overlapped stats, it became harder to create a model that accurately predicts a class. And there is a performance evaluation we have done. LDA projection shows overlapping Pokemon types, indicating that predicting Pokemon types based on stats alone is a challenging classification problem. And in conclusion, we used to have which helps LDA finally helps in understanding classes survivability, but Pokemon type is non-linear problem. In the future, work could explore incorporating additional features such as move types or abilities to improve classifications. And if you do have any questions, like post down to the reply, so I would take a moment to answer those. And thank you for giving me the opportunity to uh, present the case study. Thank you.